In this section, we'll apply the terminologies we have learned through some actual examples. At this juncture, let's pause and do a recap of the terminologies and functions. The domain of F is the set of all elements in X. The codomain of F is the set of all elements in Y. To get the image of an element in domain X, we should follow the arrow from X and go towards the elements in codomain Y such that Y is equal to f of X. To get the range of F, simply pick up the elements in codomain Y that have an arrow pointing at it, or are images of some elements in domain X. To get the inverse image of an element in codomain Y, we should follow the arrow in the reverse direction so as to find the set of element in domain X such that f of X is equal to Y. In this example, we are given a function f defined by this arrow diagram, and we are asked a series of questions with regards to the terminologies of functions. Part A. What would be the domain and codomain of f? Since f relates set X to set Y, therefore the domain of f is the whole of set X, which is equal to the set consisting of elements little x, y, and z. So list them out and close them in a pair of curly brackets. And the codomain is the whole of set Y, which is equal to the set consisting of elements 4, 5, 6, and 7. So list them out. Part B. Find f of X, f of Y, and f of Z. Well, f of X is the image of X under function f. Let's focus on the input little x. If we follow the arrow, we should reach the image f of X, which is equal to 5. Next, to get f of Y, let's focus on the input little y. If we follow the arrow, we should reach the image f of Y, which is equal to 7. Finally, to get f of Z, let's focus on the input little z. If we follow the arrow, we should reach the image f of Z, which is equal to 5. Part C. What is the range of f? Well, the range of f is the set of all images. So zoom in to codomain Y and ask yourself, which elements in Y are images of some elements in X? Yes, only those that have an arrow pointing to them. In this case, only elements 5 and 7. So list them out accordingly. Part D. Is Z an inverse image of 5? Let's focus on the output 5. If we follow this arrow in the reverse direction, we will reach Z. This means that we can find an input Z such that f of Z is equal to 5. Hence, the answer is yes. Z is the inverse image of 5. Part E. Is Y an inverse image of 6? Let's focus on the output 6. There is no arrow that is pointing to the output 6 at all. This means that we cannot find an input Y such that f of Y is equal to 6. Hence, the answer is no. Y is not the inverse image of 6. Part F. Find the inverse images of 5, 7, and 4. To get the inverse image of 5, focus on the output 5. If you follow the arrows in the reverse direction, you will reach the two inputs X and Z. This means that we can find input X such that f of X is equal to 5, and input Z such that f of Z is equal to 5. Hence, the inverse image of 5 is the set of X and Z. Next, to get the inverse image of 7, focus on the output 7. If you follow the arrow in the reverse direction, you will reach the input Y. This means that we can find input Y such that f of y is equal to 7. Hence, the inverse image of 7 is the set of y. Note that although it has only one element, y, the inverse image is always represented as a set. Next, to get the inverse image of 4, focus on the output 4. There is no arrow that is pointing to the output of 4 at all. This means that we cannot find an input such that f of that input is equal to 4. Hence, the inverse image of 4 is the set of no element, or the empty set. Part G. Represent f as a set of ordered pairs. An ordered pair means to pair up the input and the output together within the rounded brackets. Element x is paired with image 5. So we have x, 5 enclosed in rounded brackets. Do the same for element y, which is paired with image 7. Also, do the same for element z, which is paired with image 5. Then link all the ordered pairs together as a set using curly brackets. In summary, you need to be familiar with terminologies such as domain, codomain, image, range, inverse image, and ordered pairs, so as to apply them to specific examples.